Okay. All right. Okay, so to start with, I figured I would just navigate to the Psychopy website to show everyone where they can download it. So here, if you just like Google Psychopy download, this is the first page that pops up, and this is for obviously the most recent version. But if you're interested in downloading older versions, you can select this link here, and that'll take you to older releases. And the nice thing about getting started with Psychopy is that it is like a standalone package, so you don't need to download Python separately or other dependencies separately. You can kind of just download it and it's self-contained there. So when you first open Psychopy, it'll run a test on your computer to see like how fit your monitor is for your timing precision. So it'll identify problems that you might have with like Psychopy's ability to identify your monitor refresh rate or other things like that. And I'm not showing that here because it happened when I first downloaded this and it's gone. But you can generate a log that'll kind of tell you where your problems might lie for your future reference. And then when you open Psychopy, there are kind of two main tools that you can work with. One of them is this builder tool, which is a drag and drop GUI. So this is really designed for people who are maybe like less familiar with Python or less comfortable coding their experiment and want to just be able to drag and drop your stimuli. And so I was just going to kind of go through some of the demos that Psychopy has like pre-installed here, which you can find up here in the demos tab. So this one is a Stroop experiment. And here you can kind of see the general logical flow of the builder. So when you initiate different parts of the experiment, you can drop them in the order that you want them to appear. So here's the instruction screen. This is the trial itself. And then this is like the exit thank you screen. And you can kind of specify the stimuli that you want on each of those in these tabs here. These are referred to as routines. That's just like the discrete parts of the experiment. And so if you insert routine, you can kind of tell it where you want to go, where you want it to go in order, and that's easy enough to use.
Can we add one after things just to see?
Sure, yeah. Just do new. Call it after thanks. And then it'll ask you kind of where you want it to be placed. And so I'm just going to put it here. And then after thanks pops up and it's just a blank timeline. There's nothing that we have. But here I can, for example, add text that says after thanks, something like that. And here you can kind of start seeing how you can customize the stimuli that you want to appear. So this is not the actual text itself. This is just the name of the text object that you're inserting here. You can also tell it how long, when you want it to start in this timeline behind it, and when you want it to stop. And then also how it's determining the duration of the stimuli being on the screen. So here, you're asking it to be measured in seconds, and that's kind of the default, but you can also measure it in terms of frames, like number of frames flipping, or these other options, which I'm sure you can find what they are in the docs. Cool. And then the other thing is too, which I'll show you in a minute, you can use an Excel spreadsheet to kind of organize how you want your conditions to appear or be randomized in the trial, which is handy. So here, if you have some kind of variable trial to trial that you want to insert with every kind of iteration, you can, that's here is where you would do it. So you can do like a $. If you do $, and then your text, it'll look for that label in the Excel spreadsheet that you feed in, and it'll try to find that variable and replace it for every trial. And that's kind of something that's the builder is doing for you in the background. But that's just a note for using this interactive feature. Cool. So then the other thing to note is the loop. So what the loop is just basically, here you can see it's around trials, because if I wanted to repeat this trial for 5 blocks or something, you insert a loop, and then here you can specify how you want it to loop. So if you want it to randomize with the onset of every loop, you can select that, which it is by default on random. And then you can also tell it how many times to loop. So here I'm only doing it once, but you can do it for however many blocks you would like. And then here you can also play with like how you're outputting each trial's data into your CSV or this is the conditions, but in a different screen you can also show it like how you're exporting it, if you want to export it with every trial or with every block, et cetera, et cetera. Cool. So I think I'll just go ahead and play it just to give you a sense of what it looks like. It takes a minute.
And you can modify this as well.
Mm-hmm.
Because you have like other factors that you need to put in about the participant.
Yeah.
You can have either like what condition they're in or what day, or just whatever other parts of information that you would want to input to be tagged along with the participant for this particular run.
Yeah. This is also helpful in the coder as well, which I can kind of show later on. It'll make more sense. But if you want to turn on like certain flags, like for me, I will use this kind of text box in the beginning to specify if I'm running it in EEG or as just a behavioral. And that way you can use it to kind of activate flags that'll do certain things when you're farther down in your script, which is helpful. And so here's just the instruction screen like we saw.
Left to right.
Let's see if I can do this. Okay. Wait, was I supposed to pay attention to the color or the word? It's all bad. I'm sorry.
Doesn't matter.
Okay.
Let's take a look at the warnings.
I think that was in regard to the after things, because maybe I didn't specify something. Yeah, I think that's something I messed up here.
So what was the error message?
The error message is, oh, sorry, it's kind of hard to read, huh?
If time is greater than 0 and text status is equal to not started, and saying string object has no attribute status.
Yeah.
So that doesn't look like a straightforward error message.
No, I don't know what that means. This is also like I did this before of just like making my own, and I didn't have an error when I'm just dropping it in here, but I don't really know, like maybe the demo that they have already has some settings and that I'm not aware of. So that might be the source of that. But this is also, when you're using the builder, you can kind of see the output like you would if you were running it in the coder viewer, just like in a terminal or something like that. You can see your errors and your warnings. Here you can also see, which would be important to note even if we didn't get this error, that they're warning you that frames are dropping. And so that's meaning like in this laptop that I'm using, which we don't like use for our actual experiments, it's basically saying Psychopy is having a hard time inferring your frame rate, and therefore it's causing these problems of dropping frames. So that's something you would want to look out for if you were running it and just trying it on your own setup. Cool. And so let's see.
You want to just delete it?
No, I think I can use the one that we did before. Okay, so if that had worked, what it does, it outputs a behavioral log for you, which again, you can kind of specify like how you want it to be saved or what what fields you want to be included in the CSV. And I guess I can zoom in a little so it's easier for you guys to see. But here you can see, I didn't show you the conditions file either. So here's the trial type. So this is simple 6 trials, right? And this is what it's pulling from every time you run a loop and randomizing it. So it didn't, as you could tell, it didn't like necessarily appear in this order. But it's able to kind of dynamically replace the text and the letter color with every trial, which is helpful. And then it's outputting it here as well. Cool. And like I said, you can kind of customize too, like how it's recording the reaction time, what response keys you want to be accepted or not accepted, if you want all of the response keys to be kept or just the first one, et cetera, et cetera. And just for an example of how the trial might look, so here you can see that when the word pops up, it's also waiting for a keyboard response, and those are kind of drag and dropped from here, the text and the keyboard. And when you go to configure the word, that's where you're getting this like $ letter color, which is specifying what color it's going to be, and $ text. And again, these are just pulling from that conditions CSV. So simple enough. Cool. So if you want to get started with Psychopy and just are more comfortable using the builder to begin with.
I know the reason for the error now.
What is it?
Can you go back to trial?
Yeah.
Click on click on that for trial. So you see the variable is called text.
Mm-hmm.
So that means that's going to be interpreted as a string. That's going to evaluate to a string, right?
Sure.
So
yeah, from the...
Let's go to after things.
Uh-huh.
And then let's open that up. So that object is also called text.
Uh-huh.
So it's trying to... But it's not actually redefining the variable in the script. So it's actually just saying...
you're saying this is called the name text.
Yeah.
So if I have changed this to something else.
Again, then it should work.
Something else. Okay, got it. Good catch. Yeah.
So
so
make
because
sure you always
default
use-
is text, I guess, right? Yeah, because the variable is being overridden. Okay, got it. Yeah. Good catch.
So now, so I guess like as just a good coding practice in general, is try to keep track of where your
variable names.
is.
Yeah, I guess word and text are not very descriptive. But yeah.
It's a demo.
Yeah. Okay. Cool. So as I was saying, if you want to get started with using the builder because maybe you're not very comfortable with coding in Python and you kind of feel more comfortable using a GUI at first, you can start playing with this and just like inserting your images that you want to use or trying to build your trial structure. And then you can export it to a Python script, which is very helpful if you kind of are ready to transition in coding, or maybe you want to like customize it more and you're just getting like a base to start with. And this is also helpful because you can sort of see how the builder is using these like functions that are specific to Psychopy in the background, and you can model that for future scripts. So a lot of the stuff that you'll see in my script is like from some base builder experiment that I sort of like roughly built and exported to a script and now used from there. Cool. So I think next it would be helpful, because it seems like maybe most people are using this for MRI, to go through an example of just a couple things that I use to kind of customize these scripts for MRI. And this is where I am like transitioning into the coder a little bit more. So if anyone has like builder questions, helpful now? No? Did you have a question, Jax? No? Okay.
I have one question just in general.
Yeah.
So like the learning process. So most of what you've done is like go from using the builder to kind of going through the script.
Mm-hmm.
Sorry. Are there other resources? Is there like good documentation?
Yeah. So there's a lot of Psychopy documentation, like James was kind of discussing before everyone had come in. It seems like they've been working on this for a while. So there's all these kinds of support forums and documentation that you can find on the Psychopy website. I think it also just depends like how familiar you are in general with some of the concepts behind like stimulus presentation or with coding too. For me, like I was kind of telling James earlier, like there are some Psychopy specific functions that help you kind of construct your trial structure or like save data that I personally didn't find very helpful because I just like knew how to make a for loop, and I found that to be easier than trying to understand what it was doing. But if maybe you weren't very familiar or like comfortable with Python or with coding in general, then spending the time to kind of like understand how you can use those more automated functions might be something worthwhile. Yeah.
And to add just a little bit about the documentation, actually the creator of the program is really easily accessible. Like when I was having difficulties, I was able to email him, and he responded within like 24 hours. It's ridiculous.
Yeah. He's sometimes a little sassy, but it's okay. Sometimes when you go through the old like forum, you're like, ooh, did you have to be that spicy? Sorry. Okay, so for example, this is like all these import statements that I probably like a bunch of these I could delete. These are all just like from exporting from the builder, and they're just sort of left over there. Here, I'm kind of showing an example of how you might use that, like the dialog box that pops up to activate some flags. So like you have the participant information, the subject number, whatever. But then I'm also here indicating whether or not it's going to be running an MRI or behavior, which is obviously important. And you can kind of use that to throughout your script, change the behavior of your script, or even like here, I'm kind of specifying the conditions, like what ratio I want of this condition versus that condition. So that's helpful. The first thing to note too is that you have to construct like a window, and basically everything else that you'll use in Psychopy is based off of that. What I mean by window is you can kind of think of it as like the background screen that popped up that the instructions or the letters or words for the Stroop task were drawn on. So that's your kind of base visual that then all your stimuli are going to be constructed on and around. And so it's important to take into account like what units you're using for that window object and how that might interact with your monitor. And so if you're doing something like for MRI, this is a little bit more tricky, but with EEG or behavior, for us, it's important to specify like what the stimulus size are and make sure that is consistent across our different monitors and across different subjects. And even just transferring your Psychopy script from one monitor to another. It's easiest for me anyway to use visual degrees as a unit. And so what that means is basically like the distance away from the center of the screen, if you're taking into account how far the subject is away from the screen, how big your monitor is, and how many pixels the resolution is. And so that's one way to do it, which is what I'm doing here. You can see it's in visual degree units. You can also use normalized units, which is going to be highly specific to the monitor that you're using, because what that's doing is it's just taking whatever your monitor size is and it's like fitting it into a space that's like -1 to 0 in the center, and then 0 in the center to 1 on the right side of the screen, or up or down. Does that kind of make sense? Cool. So beyond that, the next thing that is important to note for me, for minimizing issues with timing, I found it to be easiest to draw my stimuli in a program like Photoshop and then import those stimuli into the script and kind of load it from the disk right away before you begin looping through your trials. So here you can see I'm doing that. I have a .png that is just like a circle or a square, and we're loading that in as this visual.imageStim object, which is specific to Psychopy, and that kind of allows you to specify the size, where in the coordinate space of the window that you want it to be drawn, and also what units that stimuli is being drawn in, if it's being drawn in normalized units or visual degrees. Yeah, sorry. So, what was it? Command equals, there you go. Yeah.
If you're pulling
Is that better?
Yep.
Yeah.
If you're pulling in the stimuli early,
Mhm.
you like later, based on the trials, like change the location of things.
Yeah.
So flexible.
Yeah, you definitely can. So the way that I'll do that, which is not the case in this script because everything's just presented in the center screen, but like in a different script, we have everything kind of moving around all the time. And so what you can do is you load in the object at the beginning, and then this position attribute of the object, you can just like dynamically change that.
I can say circled underscore filled underscore r
dot pause equals, and then you just like give it the coordinates.
Okay.
Yeah. So instead of 0, 0, you might make it like 1, 5 or whatever. So that is helpful also. It's also helpful too if you're just keeping track of like the name, so like which stimuli you drew on the screen, stuff like that. If you would want to record it, you would do like circle filled r dot name, and then maybe save that into your CSV file or something like that. So you can kind of keep track of everything that's going on here. Cool. And then next, something that might be kind of tricky if you're doing this in MRI is just like how to work with the TTL pulse that comes in from the MRI. So if we're scrolling past all this, here is where I'm waiting for the scanner to tell me that it's beginning the scan. And at the 3T, and I believe this is also true at the 7T as well, there's a box, it's called the Cedrus Lumina pad, and you have to set it to be on E prime setting and a keyboard input. And what that does is it allows Psychopy to interpret the TTL pulse as a keyboard input, and specifically it comes in as this L shift. So what this is a Psychopy function that's saying pause everything until you get this keyboard input, and then you can continue. And I have the Z in there just for like troubleshooting. But that is helpful to know. So with MRI, I'm only recording just the TTL pulse at the beginning, and from there I kind of have to depend on these other functions to tell me what my trial timing is relative to the beginning of the scan. So what I'm doing here is setting up this clock object is the core.monotonic clock. What it does is it starts your timing from the beginning of when it's instantiated, and then what you can do is you can basically sample from it and figure out how long since the beginning of your run is this stimulus popping up, or is the subject responding, or does the ITI begin, whatever.
I had a question.
Yeah.
Why do you wait for 6 seconds after you...
I don't know. Kai told me to. I think it was something about when we're using multiband, you have to allow it 6 seconds to start the shimming, or something. I don't know.
Oh, it's for like collecting dummy scans?
No, like for just running for subjects, there's something about if you don't wait 6 seconds, you can get a kind of artifact or delay or something in the bolt.
Okay.
Yeah.
Wasn't there some sort of delay?
I don't know
I know
why.
what you do.
Yeah.
Just for normal scanning, you wait a few seconds just to allow the scanner to reach a steady state.
Mm-hmm.
At the beginning, there's I can't explain it well, but the intensities are a lot higher before the scanner magnetism reaches a steady state.
Mm-hmm.
But with this, if the scanner is detecting, if the scan is started, and then you're waiting 6 seconds, and then you're initiating a clock to actually start the scan for this script to start.
Mm-hmm.
So does that mean But the scan has started already 6 seconds ago.
The scan is started 6 seconds ago, but I know that it's always going to be 6 seconds, so I can just take that into account. And the subject
Okay.
isn't seeing anything on the
Yeah,
screen
on the
for
screen.
those 6 seconds.
Okay, so
Yeah.
you like add 6 seconds or
Mhm.
what have you
Yeah.
at the end? Okay.
Yeah. Yeah.
Okay.
Or not even at the end. It's just like you know that there's going to be 6 seconds built in,
Okay.
and so you have to take that into account when you're like doing the stimulus timing, like what I was telling you about.
Alright.
Cool. And then I'm using a different kind of clock object to record reaction time. The difference between these two is that the monotonic clock, once it's defined, you can't kind of reset it to 0, which is helpful if you're trying to record the time since the beginning of the run. But for the reaction time clock, you kind of want it to be able to be flexibly set back at 0 for every trial, right? And so I have two separate clocks for that purpose. And then I can go through and kind of show you too how I'm displaying the stimuli on the screen. So like in this trial dictionary, this is where I'm specifying what particular stimuli I want to be drawn. Maybe I'm trying to put a filled circle up on the screen. What you have to do is you call on that visual.imageStim object that you constructed earlier and like loaded your .png into. And then you have to say, if you specify .draw, it doesn't appear on the screen until you actually flip the window. And what that is sort of like refreshing the window, so updating it with the stimuli that you want to be drawn. And then here is an important note. Here I'm using core.wait, which is a Psychopy function, which basically pauses the script for the amount of time specified. I found that this function is not very precise in its timing when I was testing it using EEG, testing it with an oscilloscope. What worked better there was actually kind of customizing this feature and writing a function that determines the amount of time a stimuli is up on the screen by how many window flips it takes to get there. So that means you have to take your refresh rate of your monitor into account, and the amount of time, if you do it this way, the amount of time that you would have your stimuli on the screen has to be like a multiple of that refresh rate. And for me, that improved the variability that we were seeing in the timing a lot. Here, we didn't think it would quite matter as much with MRI just because the temporal resolution is not as precise. But we might play around with this because we are kind of seeing this weird lag that we don't know where it's coming from. So there's
Can you show us where there's a library of commands and what they might do?
Yeah. So that would be like where the docs are. And let's see if I can just go to documentation.
As you're saying, some of the things are related to, the syntax is based off of Python, but are there Python type things that are creeping in here that you want to know something about Python as well in terms of
absolutely.
commands and things like that?
Yeah, so you do have to know Python to be able to code this. Like the Psychopy specific functions are really using like the kind of intuitive structure that Python in general uses. So it is helpful to know Python if you're trying to do this. And like for me, like I had mentioned earlier, I wanted to really be able to like customize how my conditions or how the trials were structured, and I found it easier to just like code that in Python versus using Psychopy's way of doing it. So it's really kind of just up to you and your comfort level with that. Yeah. And here there's like all of these tutorials that you can go through, and also there are documentations for just like the specific syntax of so for example, like if you, I don't know if any of these will let me select
I
them.
could go back to the previous page. There's an API reference link as well at the top. Check the reference manual API for
This
further.
package too is that some of the Psychopy built-in functions really can be quite intense and beautiful graphic displays that I think would otherwise be extremely difficult to code in some other languages. I don't know how much it's true to say from that lab, but even just in the tutorials, you see some really, I don't know, some of this like very fancy, like ridiculous looking graph. Not that anybody's doing that, but that's the idea. Right. If you wanted to have some idea for this, it's a complex graphic display with Psychopy, like easy ways of doing it to save time.
Yeah. But it does have pages like this that basically tell you for all of these, what I've been referring to as like Python objects. It's just basically like classes that Psychopy has that are specific to Psychopy that have all these different associated attributes and functions. And so, for example, like I was referring to core.weight, that's an example of this Psychopy.core class, which then has all of these different functionalities that you can do, and they're all kind of laid out here. So,
question about sorry, it's probably a dumb question, but the refresh rates and the monitor rates, but if you're doing it in the scanner, you're not looking at a monitor, they're looking at a projection on the screen?
Yes.
So how do you handle that?
So that's where we think like some of our problems with like the lag that we are seeing might be coming from. It's not totally clear for us right now. Like we're using the refresh rate of the PC that's in that 3T room, and even though we're testing kind of the same version on our computers using EEG, and it seems to work fine, but then when we're transferring it into MRI, they seems to be having these problems. And so we need to just test more and maybe pull Alan into the mix to see how it's interacting with the monitor and maybe how that might be affecting the timing. Because, yeah, that is kind of an additional component. It's not that they're looking directly at the monitor, they're also looking at the projector. So the way that it's interacting with the projector might be introducing these issues. I would think that would be the case no matter what stimulus presentation you're using, but I'm not totally sure. So I think the only thing after that would be important for MRI users to be aware of is that the MRI is sending a bunch of like random characters that I'm sure can be interpreted by someone, but not by me, as keyboard inputs. They're just like a bunch of symbols that come in as each volume is being collected. So you want to make sure that your Psychopy script isn't like in any place being open to keyboard inputs that you are not intending on recording. So a good example of that is when the subject is supposed to be responding. I have this function that's event.getKeys, which basically just like monitors the keyboard inputs that are coming in and retrieves them for you. And what I would not want to happen is for it to record every time a signal from the scanner is coming in. So what you can do is you can specify what list of keyboard inputs are acceptable, which here, yes key, no key, just refer to 1 and 2 on the keyboard. Those might be different if I'm doing it as like a behavioral study instead of waiting for the button box. So that's why it's encoded as like a variable here. Yeah, so that's just important to keep in mind if you're doing any kind of like wait for keys, keyboard input things. You would want to make sure that you're only recording the keys you mean to be paying attention to. And then this is also an example of how I'm using the reaction time clock. So you can kind of just reset it right before you flip the window that the subject is supposed to be responding to. So if they're responding to here is a picture of a face or a scene, you reset the clock and then flip the window immediately after they see the picture of the face or scene, and then you kind of get a timestamp from that reaction time clock. And then all of these things can be recorded in a behavioral a log of the behavioral data, the reaction times, and all of the conditions, all that, and accuracy as well, of course. So
this one will get all responses. So if they press like twice during the trial, it'll
get keys. This one, by default, it only does the first response, but you can have it get all of the responses. Okay. So I'm not specifying that here because by default it's only grabbing the first one. But if you wanted to record any and all of the responses that they're making, you can specify that in this get keys function. Yeah.
Is there any chance that the MRI input that would be coming in, like those random keys, that it would just by terrible coincidence happen to be that signal?
If so, then that would be kind of a problem of the like technicians and not anything that you could control in your Psychopy script, because it's just how the button boxes that the subjects are using to respond with are like what's output they're giving. And so there's not really anything that you could do in your Psychopy script that would like protect against that. That'd just be a problem of like the equipment that you're using or how it's being translated into a keyboard input. I don't know if you tried to like, yeah, I don't think there's any way that would work around that. But we haven't had that problem so far. So the MRI just outputs like pound signs, dollar signs, like it's a bunch of non alphabetic or like non-numbers. So in the MRI, the button box just outputs 1, 2, 3, or 4, the one that we're using. And so that would definitely be something you would want to take into consideration. But if that were the case, you'd probably need someone else's help to fix it. Yeah.
If those are all symbols and not numbers, then it seems fine.
Yeah, then it should be fine. Yeah.
Could be anything.
Yeah.
You don't know.
But it is another thing to keep in mind, like when you are setting it up even, and just like, for example, for us, we collect always like a T1 first, and then we run the script. So if I have my like Psychopy script open and the cursor is just sitting around, sometimes if the Cedrus board is set up and I forgot to like turn it off or something, the symbols from the scanner will just come in and like launches into your script. So you want to be careful of like, be wary of that. Just like make sure to turn it off when you're not actively recording from the subject, kind of thing, which the technicians are also really helpful in remembering that. So
Did we have, I haven't done MRI for a couple of years now, but was anyone using, are you guys the only ones who use Psychopy with the MRI?
I believe so, yeah. Yeah. I don't know how many other people are doing like functional studies, though. I personally am not aware of many other people that are. So, but those that are, I believe, use ePrime. Yeah. Cool. So the one other thing that I can think of that might be important that I didn't think of when I was first doing this is that you want to make sure that you're, if you're jittering your ITI, that it's kind of adding up to the same amount of time for every run that you're going through. So instead of just purely randomizing it in your code, you want to make sure that you're pulling from some list of ITIs randomly so that you know every block adds up to the same amount of time for every run and every subject. And so what I'm doing is I'm pulling from a text file of ITIs, and I know that those all add up to like six minute and 18-second run, and I'm just also pulling all of those and randomizing those in at the beginning and then looping through them in the trial in the for loop. So awesome, cool, and I think that's all.
Cool. I have a question about how it works with EEG.
Yeah, absolutely.
Is there just, like a different kind of the way you had the MRI markers coming in? Is there another way you send like TTL pulses?
Yes, totally. And I can show you that here actually. So what I'm doing for EEG is we have a serial port that Psychopy sends bytes out to, and then those are being embedded in the data, in the EEG data file, like by the EEG software. And so these are all triggers that I have for each stage in the trial, or for like, if you want to specify conditions, you can also just make them different numbers, and then you know that that's what that condition was. So this is different conditions of the cue, which is just one part of the trial. And then, like I mentioned, the subject is supposed to be responding either to a face or a scene. So I also made those different triggers. And what you do is you just like send those out. I'll show you actually. There's a function called win.call_on_flip. So what this is doing is whenever you next flip your window, it's running through whatever function you specify. So port.write is the function to send these bytes to the serial port. And I'm just basically telling Psychopy, whenever you're next flipping the window, then send the bytes to the serial port. And I'm doing that just to try to be like as precise as possible with the timing there.
Is there a different option that's less precise? Like what's the...
Yeah, you could just do port.write and then it'll just do it before you flip your window a little bit. Like, I don't know how much difference it really makes, but I was just, trying to be fancy. So yeah, so you could just write here like port.write, and then whatever your trigger that you want it to be, and then it'll flip the window and send it, or it'll send it and then flip the window. Yeah.
So so you have it before, so that you're saying when you flip the window, send this cue trigger, and then it's flipping the window to show the cue.
Yeah.
Okay.
Yeah.
I thought the cue was happening before, so then I thought it was waiting longer to send the trigger.
No. So it's trying to make it as simultaneous as possible, basically.
Yeah,
like I said, I don't know realistically how much difference it makes, but
Psych toolboxes.
Oh.
I don't know at what point I'm sending the trigger.
Oh,
exactly,
yeah.
In comparison to like when the actual cue is being displayed.
Sure.
That's helpful.
Yeah.
But you can say when you're actually like doing that thing.
Yeah, exactly. Just trying to be as simultaneous as possible.
Yeah,
Mm-hmm.
that's nice.
Yeah. Cool. And then just to point out too, like the flags. So basically I just like activate this flag when I open up that dialog box, and you can have it like default to activate the EG flag or not and whatever. So that's also kind of handy just as a general like coding tip. So cool. All right. And you can also see here that I'm using like the window flipping functions instead of the core.wait. That's something else that you might want to take into consideration if you end up using Psychopy for EEG, because I found that made like a really big difference in terms of if just testing it, looking at it with an oscilloscope, like the delay was very consistent and predictable when I used this instead of using their like core.wait feature.
Have you got your function you can share with me?
Yeah, absolutely.
This is on GitHub.
Yes, it should be. I need to update it though, probably. So this is the function that I wrote. This is just the time that you want it and then what stimuli you're trying to draw. And it's basically just like calculating how many frames would be required to fulfill that interval based on your refresh rate that you also need to specify. And I use this to kind of get around on one of our monitors. Psychopy was having a hard time actually like finding the refresh rate, which as you saw like gave all those warnings and stuff. But here I just am basically hard coding the refresh rate and customize like doing it myself. And that seemed to work better. So helpful. Cool. And you can also do like for drawing your stimuli, there's this is like a small note, but you can do auto draw, which basically just like for all window flipping until you turn the auto draw off, it'll just draw that stimuli. So for example, like a fixation cross is on every window that we want. And so you just turn fixation cross, the dot auto draw equals true at the beginning of your script and set. You don't have to like manually type it for every time you flip your window, which is helpful. Yeah.
Yeah, I can include a link to the GitHub. If
Yeah.
that's all right.
Yeah, absolutely.
I can put that in the notes and I can send that to everyone here.
Sure.
That would be good. And then,
Do you have any comments or experience with sound presentation?
No, I don't use sound, so I haven't required. From what I've read online a little bit, it sounds like using sound has more timing issues than the visual presentation, but I haven't like looked into it because I don't use it. So that might be something that might be a caveat with using Psychopy that I'm vaguely aware of. So yeah.
And maybe it goes without saying, for users of Windblows, you would want to have some sort of virtualization in order to use this.
I don't know what
Like
virtualization
using a
means.
virtual machine, or
Like, does this work on non-Macs? Is that what you're asking?
Oh,
Yeah, do you need
Does it?
Spider basically in order to use it in Windows, or does it actually standalone?
it's actually standalone. Yeah. Actually, all of our stimulus presentation are on Windows using Dell computers, not this Mac. So yeah. But I am able to ran it on this Mac just fine. There seems to be able to go back and forth. Okay. Yeah.
Do you have to do anything specific?
You just download the Mac OS version and it's fine. I did note when I was looking on Psychopy's docs earlier that it seems the more recent Mac software is problematic for their timing. They noted that was true across like all different. So I don't run experiments with the Mac, so I haven't really like paid attention to that. But if you are trying to use a newer OS in Mac, that might be a problem for you.
That is true of Psychopy.
Oh, okay, yeah. They made it sound like it wasn't unique to them. They're like, but, but yeah.
So I'd be interested actually, if you're using a scope to check on timing, which is
Ah.
very wise.
Yeah.
I'd be interested then if you would be willing to spend the time to test across different platforms and see if you get the same timing ability.
You mean across Macs and Windows?
And the Linux box.
Yeah. So we have had limited experience using it with a Mac, and the reason why is because we were like testing lesion patients in the hospital, so it kind of had to be portable, and all of our laptops are Macs. Actually, when we tested the Macs using the oscilloscope, actually on his computer, our timing was problematic. So it worked better. We actually ended up purchasing a PC laptop that we could use for these lesion patients because it seemed to be more problematic on the Macs. Why, or if it's dependent on what Mac you're using, I don't totally know. But yeah.
There are blogs curious too.
Yeah.
Sure there are.
Yeah. But actually, so Kai had an older Mac that we ran it on, and the timing was okay on that. But then his is a slightly newer one. I don't know what version, but
The latest version.
oh, the latest, yeah, yeah, yeah.
Because the documentation said, as soon as you got to 10.12.
Yeah.
Up until 10.12, so on 10.13. And that's when the triple buffering.
Yeah.
Might cause some timing issues. Yeah, have you tested on Linux?
No.
Okay.
Yeah.
But presumably it works.
Yeah. There's nothing getting in the way on Linux.
We think. But that's what I'm saying. I'd be really interested. So you have had some experience, basically, trying across platforms, and depending on. But I'm not sure if we didn't test it on many different Mac laptops. Like maybe it was something about the fact that his like hardware is just older. Maybe that's the problem, or maybe it's the OS version. We're not totally sure what the source of that problem is. But yeah.
Psychopy does have a big page about timing issues.
Yeah.
So you can run through like their entire page to see like what types of troubleshooting. You can go through and other types of things that you should check to see like what are the mistakes that can, or what are the timing errors that can cause that are caused by drivers and operating system.
Yeah.
From what you're
I had that up
how you're
here.
coding it, or what type of keyboard you're using. They even have a section on audio delays, which would be relevant.
Here, yeah.
Yeah. And they have a section for like non-slip timing for imaging. So that was that was also just kind of using the clock that Dillan started at the beginning of her experiment, and just making sure that everything occurs relative to that clock somehow, so that you can keep the timing consistent, so that if you have dropped frames, it doesn't accumulate error over time.
Yeah.
But yeah, the best thing is to use a computer that doesn't drop frames.
Ideally.
If anybody's curious of playing around with Psychopy scripts that have been used in different populations, the Connectome Project's aging lifespan studies all use Psychopy tasks. So they have the development scripts with your tasks.
had a 3T Siemens whatever the newest version is, so I don't know how much different that is than troubleshooting between a GE and a Siemens for a Psychopy. It shouldn't be a problem, I would assume, but who knows?
Who knows? Yeah.
Any other questions?
Cool.
All right.
Thanks.
Well, thank you.
Of course.
so
Yeah.
much.
Hopefully it was helpful.
That was awesome.
Should I stop the recording?
Yeah, you can stop it.